If you stumble across a mulberry tree, you might think you found an oversized raspberry bush, but botanically, they aren't even in the same family. A mulberry is a multiple fruit. It doesn't grow from a single flower. Instead, an entire cluster of flowers swells and fuses together into one cohesive, nutrient-dense structure. For over 5,000 years, this genus has been an essential partner to human industry. Because the domesticated silkworm requires mulberry leaves as its exclusive diet, the expansion of the global silk trade across millennia has effectively determined where these trees are planted and naturalized today. Many researchers view the mulberry as a biological miracle. It carries a dense matrix of phytochemicals and a unique pharmaceutical capacity to bind with receptors in the human gut, effectively regulating how we process sugar and metabolism. But there is a darker profile. It secretes a toxic, hallucinogenic latex, harbors grotesque fungal pathogens, and can function as a highly aggressive invasive weed that destabilizes local ecosystems. To understand how one plant can be both a medical savior and a biological menace, we have to look at how humanity aggressively exploited its hidden superpowers for 5,000 years. The global journey of the white mulberry, Morus alba, was driven entirely by the silk trade. Because its leaves are the only thing a domesticated silkworm will eat, any nation that wanted to break into the textile market had to import and plant the tree first. While the insects use the leaves for growth, humans have discovered they contain a potent pharmaceutical compound, 1-deoxynogeremicin, or DNJ. DNJ is a piperidine amino sugar, a molecule that is structurally shaped to mimic simple glucose. In our small intestine, an enzyme called alpha-glucosidase breaks down complex carbohydrates into absorbable sugar. Because DNJ mimics the shape of a sugar molecule, it locks into the enzyme's receptor site first. This competitive inhibition prevents the enzyme from processing the actual carbohydrates you've eaten. This biochemical block severely slows carbohydrate digestion. By preventing a rapid influx of sugar into the bloodstream, it blunts the typical post-meal glucose spike. Clinical trials show this can lower the glucose curve by 42%, which in turn suppresses the massive insulin surge typically required by the pancreas. The fruit itself is equally dense with nutrients, containing a matrix of anthocyanins, powerful antioxidants, and a protein content reaching up to 12% when dried, which is unusually high for any fruit. To preserve these nutrients, ancient cultures in the Near East developed a form of physical chemistry. By adding calcium carbonate from alkaline pekmez earth or wood ash, they neutralized the fruit's harsh organic acids. This clarified the juice, allowing it to be boiled down into a shelf-stable molasses called pekmez. For millennia, we successfully harnessed these intricate biological traits, using the mulberry to fuel global industries and provide vital metabolic medicine. That relationship changed in the 1830s during the American Mulberry Craze. Investors hoping to dominate the domestic silk market triggered a speculative bubble around a fast-growing variant called Morus multicollis. Within 2 years, prices for saplings spiked by nearly 700. This left behind millions of abandoned, highly adaptable white mulberry trees. As an aggressive pioneer species, these trees quickly escaped the failed plantations and began colonizing everything from fence rows to abandoned urban lots. This proliferation created an ecological crisis called genetic swamping. The invasive white mulberry produces massive volumes of pollen, asymmetrically hybridizing with our native red mulberry. We're effectively watching the native species be bred out of existence by its invasive cousin. This unchecked monoculture also provided a perfect host for specialized pathogens, specifically a necrotrophic fungus known as Ciboria carunculoides, or popcorn disease. This fungus targets the reproductive organs of the tree. It infects the developing fruit, digesting the healthy tissue and replacing it with a hardened vegetative structure called a sclerotium. These grayish-white growths swell and erupt from the berry, making the fruit look like a piece of popped corn. What began as a get-rich-quick scheme permanently altered the chemistry and genetic makeup of the North American landscape. In the mid-20th century, city planners wanted the rapid growth and shade of the mulberry, but hated the mess. The fleshy berries stained sidewalks and parked cars, creating a constant headache. Their solution was a botanical hack. The mulberry is dioecious, meaning individual trees are either exclusively male or exclusively female. To keep the streets clean, they simply stopped planting the females. They mass-planted strictly male, fruitless cultivars. But there was a fatal flaw. In a natural forest, female trees act as biological traps, intercepting and binding airborne pollen. In a city full of only males, that pollen has nowhere to go. It remains suspended, correlating directly with a fourfold increase in asthma and eczema cases. Beyond the allergies, the tree's milky latex contains compounds that overstimulate the human central nervous system. When ingested, this sap causes severe gastrointestinal distress and powerful hallucinations. Because of these health risks and the tree's aggressive root systems, many municipalities have now enacted total legal bans on the planting of Morus alba. The mulberry isn't inherently a miracle or a weapon. Its status today is a reflection of human hubris. By manipulating its biology for the sake of clean sidewalks and quick profits, we turned an ancient industrial partner into a modern biological menace.